Hello, Julian here from PopcornFX. Today I'm going to show you the new texture viewer in PopcornFX 2.6. So now when you double-click a texture in the content browser, it opens the texture viewer window where you can inspect the different channels of your texture, where you can zoom in and inspect some specific texels, see their 8-bit and HDR values if it's an HDR texture, where you can preview the sampling performance, change the intensity to spot dark regions, or for HDR textures to better inspect the darker or brighter regions. You can also cycle through the different mipmaps if your texture has mipmaps. If it's a cube map, you'll be able to see each individual cube map face. And there is also a texture export dialog that allows you to save the texture in a different format, a different pixel format, and where you can export each cube map face separately to a different texture, choose the bitmap range, etc. So let's start by looking at the channel visualization. So here in the viewport panel, you will see RGBA toggles that allow you to selectively show or hide each channel. Textures that do not have alpha won't have this alpha button. You can also zoom in the texture using the mouse wheel. When you are zoomed, you can pan the texture using left click, and right click selects the texel under your mouse, so that when your cursor goes out of the viewport, the selected texel will be displayed here. Whenever you are inside the viewport, it's the texel under the mouse that is displayed. So these two buttons here allow you to quickly go between a 1:1 scale. So here one texel in the texture is 1 pixel on screen, and the other one is just a fit to screen button. If you have a cube map, right next to the fit to screen button and 1:1 zoom, you will have two drop downs, one of which is the cube map face to view. Next to it you have the list of all the mipmaps, which you can preview. So note that this cube map is also pre-convolved to be used as an environment lookup, so each lower level of the mipmaps is more and more blurred, which you can see here. Then if you have an HDR texture, you can use the multiplier slider here to quickly inspect high or low intensity details that you wouldn't be able to see otherwise. And here you will note that when I hover the bright parts of the image, here in the HDR column I have values, the actual HDR values, which are greater than 1, and the sliders here display the normalized color, so you still have the actual color tint of the image at that specific point, and you don't have it displayed burned out as in the preview here or as in the actual viewport. And you can also inspect volume textures, for example this 3D noise texture, and use this slider here to scrub on the Z coordinate or the W coordinate, which allows you to see each slice of the texture. So in the details panel here, you have the various information about the texture, its type, format, the dimensions, the size it takes on disk, the coordinate of the hovered UV and texel, the RGBA values, and the color represented as HSV, which might be useful in some cases. And we also display the hexadecimal representation. So this is a web color format, so that's ARGB. So you cannot edit any of these. They're here just for information, but you can copy paste them if you want. Next to the hex display, you'll see Find Previous and Find Next buttons. So these are actually shortcuts to find the next texel which has this color in the texture. So you also can do this search by clicking this button here, where you can type the value of a specific texel. I looked up the value of that texel beforehand, I just didn't type it by heart. So here it found this texel, and I can search for the other texels. So here I don't have that many. Looks like I have 8. You can also use the F3 and Shift F3 keys to search backwards and forwards. Next, we have the sampling information section in the details panel, which show you a zoomed in view of the texture at a specific point. And this is different from this view here because this is displayed by calling the runtime, the PopcornFX runtime sampling functions, the same ones that the particle simulation uses to sample the texture. So this is the actual view of the texture as seen by the particles, and you can change the same things you can change in the simulation graph. So you can switch between point and linear sampling. Quick side note here, if you're sampling a texture in the particle graph and you're not getting the values you're expecting, this could be a runtime bug, even though we're not aware of any. So using this view allows you to make sure it's a runtime bug or not. So if it's a runtime bug, you will see messed up values in this view as well. So make sure to drop us a mail if that's the case, or notify us in one of the communication channels. You can wrap the texture or not. So here, for example, it wraps, so when I go out of the texture, I see it goes back on the other side. So here I will start having the blue of the vial here. But if I set it to clamp, now all of a sudden, as I go near the edge, it's just the same colors that extend past the edge. Again, wrap. Yeah, this is a bit hard to see. Here I see the corner and the bottom corner that wraps back, whereas in clamp mode everything just extends past the limits of the texture. Right below you have the benchmark mode, which is similar to the vector field viewer and mesh importer benchmarks. So you can activate it by clicking here, and when you hover the texture, it will give you the cost, the runtime cost of sampling the texture when done in a particle simulation graph. So here I'm around 7 cycles per query, which is pretty low. You will notice in the viewport the small circle around my cursor. If you keep the Alt key pressed and use the mouse wheel, you can change the size. So this is the size of the area where the query probes are thrown. So the benchmark works by doing a bunch of probes, like it samples, for example, 300 probes at 300 locations on the texture. Within that circle, it averages the cost of all these, and it displays that cost. So here, this average cost is around 7 cycles. The point of changing this is so you can preview the effect of CPU cache. So that's a pretty advanced topic. You have a bunch of settings in the texture viewer setting to change that. You can show the location of the actual darts that are used to do the sampling, but I'm not covering this in this video. It's a detail. So here, if I switch to linear, we will go from 7 to 21 cycles. So this gives you an idea, of the cost of linear sampling compared to point sampling when used in particle simulations. Note that this cost is only for CPU simulations. You probably do not care at all for GPU simulations, as the sampling is done in hardware anyway, and you can consider it is pretty much the same cost wherever you pick point or linear or clamp or wrap or whatever. Also, here you will see the format is displayed red. This is because the texture here is an etc1 texture, and the runtime on CPU cannot sample natively etc1 textures. So here it tells you that when you use this texture in an effect in a texture sampler, when the effect gets loaded, a runtime conversion will happen, which is not a good thing because it can cause frame rate spikes when effects are loaded or streamed in as you progress in the in-game level or whatever. So ideally, when you use CPU sampling, you will want this to appear green, such as, for example, this texture here. So here the runtime can sample 16-bit floating point RGBA textures, but it cannot sample etc2 textures or etc1 textures. If your texture is in the BGRA8 format, so 8 bits, it will also be able to be sampled efficiently at runtime, so no additional cost to convert the image. Another thing that pretty massively impacts the sampling performance is whether or not the texture is a power of 2. So here, let's say I'm opening this texture. This is a power of 2. It's 256 by 256, so this is fine. Here I will have high performance, 7 cycles. That's good. However, if I open almost the same texture, here it says not a power of 2. And when I enable the benchmark, here I'm going from 7 to 36 cycles per particle or per query. So this is a pretty massive degradation in sampling performance. So make sure you always use power of 2 textures when using texture samplers inside PopcornFX. And the last thing we have is the export dialog. So the export dialog allows you to save a texture into a different texture and change the format, the file format, the pixel format. So here I have a BGRA8 texture. Let's say I want to save it as DXT1 or BC1. Let's keep the sRGB flag. And I hit export. And now I have my new texture here, which is DXT1. So depending on the type of texture, you will have some more controls. So if you have mipmaps or if it's a cube map, you will see some different options here. So here I can select the mipmap range I want to export. I can select if I want to export a specific cube map face or not. So when I change this, you will see the final file size preview that will update. So here in BGRA8, this cube map is 32 megabytes, which is pretty massive. You'll see that when I cut off the lower mipmap levels, it doesn't change much, but let's say I'll just want to save it as 512 instead of 1024. And I'll still cut off some lower mipmaps. And I will save that as, let's say, BGRA4, which will cut the file size even more. And here the export failed. So this is because some of the image writers do not support all the formats that are listed. So the formats that are listed here are the formats supported by the current file format. So here I'm saving as DDS. I could write any of those pixel formats into the DDS file. If I choose PVR, I can write even more, but if I choose instead PKM, I can only write the etc file formats. And if I try to export into etc1 something that was BGRA8, it will also fail, because the editor currently isn't able to convert from BGRA to etc, so it can't compress etc basically. So this is something we will probably add in future versions, but it's pretty low priority right now. So if instead of BGRA4 I tell it to write BC1 again, now it's down to 1 megabyte, so even better. And this will work because the editor is able to compress to BC1. So if I hit export right now, I will see a warning window saying that my extension is mismatching. So this is just because I changed it to PKM right before. Right, so now my new texture is exported. So there seems to be a bug in the content browser where the thumbnail does not refresh, but I saved it onto this texture, and here we indeed have the cube map, and we can see that it is indeed DXT1. We have the mipmaps starting from 512 to all the way down to 4, so that's what we wanted. And that's it. If you have comments or suggestions, don't hesitate to post a comment in the comments section down below. Thanks for watching.